Hey, this is Jedley, and this is another STEM is Family Fun experiment that you and your parents can do at home. Joining right now from the beautiful island of Puerto Rico, Monica Rivera Sosa. Hey, Monica, hola.
Hi, Jed. Hola. Hi, Whitney. We're so excited to have you back. And I'm so excited for another awesome, exciting experiment.
That's
Thanks, Mama. So excited to be here.
That's right. Joining us from the San Diego Children's Discovery Museum is Whitney Raser, the Director of Education. And Whitney, before we start, how cool is it working in a children's museum?
It's the best job. It's a dream job. I literally call it a unicorn job that I got to be here and do fun things every day. I like to call it undercover learning. There's all kinds of stuff that happens on the floor of the museum, but we believe in hands-on play and purposeful play. So all of the learning that happens is really through play and through open-ended exploration. So it's a very fun place to be.
And that sounds much, because we have some great museums here in Boston. You know, you told me you lived in Boston, and but when I go to the Museum of Fine Arts, if I go near a painting, they're like, great, like there's no touching there.
Yes, no, and for us, it's total opposite. It's please touch, please play, please experience this so that you can learn and take away from it.
Awesome. Monica, I don't know about you, but I'm really excited, or as we say here in Boston, I'm like wicked excited to see what Whitney's going to do today.
Absolutely. And you were telling us a little bit about the experiment before we started, but you wanted to tell us that it might get a little messy. And personally, I think that's even more fun than anything else.
Yes, this is a potentially messy experiment. So anybody listening at home, if you're doing this, you might not want to wear your favorite t-shirt or your favorite, dress or pair of pants. And it's one that is really good outside too. If you're a grown-up listening and want to try this at home, it can be messy. It might also be not so messy, but it definitely can get a little big and messy, but it's very fun.
That's kind of part of the fun of science, isn't it? It's because you never know.
Yes, it's true. This is one that you don't know exactly what it's going to be. You might do it one time and you might change one small part about it and it becomes a huge, huge, big mess. And you might do it another time and it's a small mess. So we're going to get to see today what kind of mess we get to make together.
Awesome. And Whitney, I heard this thing, because we've interviewed so many different scientists and engineers and all these really, really smart people. And they've told me, it's hard for me to believe, they told me that when it comes to science and technology and engineering and math, and if you make a mistake, that's okay, because you can learn from your mistakes.
Yes, the mistakes are actually good. So mistakes are what scientists look for. If something goes wrong, and they change that one small variable is what they call it, to see if they can alter an experiment for next time. So each part of science is seeing how you can adapt something or fix something. And engineers do that too. We like to say at the museum that engineers are problem solvers, and that you can always improve a design, right? So there's, the cars that we drive now look super different than the cars that we were driving when they were first created. And that's because engineers have improved them over time and solve different problems, because lots of different things can happen when you're doing experiments.
Wow. I would have been a really good science student, because I mess up all the time.
And you're already acing science.
All right. So what are we going to do today?
Great. So we're going to do a really fun experiment called Elephant Toothpaste. And so this isn't toothpaste that I would recommend, though, brushing your teeth with. It's just part of what it'll kind of make sense at the end, but know that the things that we're going to put together are not things that you should actually eat. And you should probably ask your grown-up before you do this experiment at home too, if you're a kiddo listening. But so some of the things that you're going to need are a plastic water bottle. So we're just using an old soda bottle. This is something that's great to recycle in this fun experimental way. So we're going to use that. You're going to need some dish soap. So soap that is liquid dish soap. So not the hard soap that you'd wash your hands with, but the liquid dish soap. Food coloring, a little bit of hydrogen peroxide. And this is where I was saying your experiment can look a little different. So we're going to use a special hydrogen peroxide today, which is like the hydrogen peroxide you can use if you want to change the color of your hair. But you can also just use the hydrogen peroxide that's at your house. There's just some hydrogen peroxides are a little bit stronger than others. So we're going to use one that's 10%. And then you need a little bit of yeast. So active yeast is something that you might find in your kitchen, or you can find at the grocery store. And then other tools you need are potentially a funnel if you have that, but you don't need one. You guys ready?
I'm ready. I am ready. My elephant needs his teeth brushed. So let's get it together.
Okay, so we're gonna get to do this experiment. There's a couple of different steps, and along the way, I might ask you all some questions, and I might ask you to make some predictions or hypotheses, which are smart guesses to think about what is going to happen and why you think that's going to happen using what you know. So the first thing we're gonna do is we're gonna take our empty bottle and we're gonna measure out a 1/2 cup of hydrogen peroxide. And I'm gonna use my funnel to help me put this into my bottle. If you wanted to not use a funnel, that's okay too. Remember, we said this one might just get a little messy, and that's okay. I'm gonna pour in my hydrogen peroxide into my bottle. I'll make sure it's all in there. Perfect. And then this part's really fun. You get to take some dish soap and you just get to give a big squeeze. There's no right or wrong amount to put in there. You just give a big squeeze. But, you know, Jed, your big squeeze might look different from my big squeeze. And Monica, your big squeeze might look different from Jed's big squeeze. So this is one of those things with science, right? Where this is a variable. So how much soap you put in could really change each time. And that could change kind of what you see at the end. So that's just sort of something to keep in mind too.
You think, should you keep, like, should you remember how much you put in each time you try it so you can do different amounts?
Yeah, that's a great thing that scientists do. So if you really wanted to, you could measure out each time exactly how much you put in, right? So I measured out exactly 1/2 cup for hydrogen peroxide. For my big squeeze for the soap, I didn't measure that out, but if I wanted to, I could have measured out, today I'm gonna do a 4th cup. Today I'm gonna do a 3rd cup and see what the difference is after you do that. So that's a great idea. So I've got those two substances together in my bottle. I'm gonna put the top on and I'm gonna give it, this part's also really fun, a big shake. So you guys want to dance at home, do a little shake, the side to the other side. We're gonna shake that all up. Okay, so you should see it all shooken up, all shook up. And then this is where Monica and Jed, I have a really critical question for you all. What color do you think we should put in? It can be your favorite color. It could be, you know, a color that you just think is fun. Here's some choices. We've got red, blue, yellow, green, but I can also make colors by mixing them together. Any votes or choices?
I don't, Monica, you are a student at Emerson College. Do they have like a college color?
I'm so glad you asked. I think we should do purple just to honor my wonderful Emerson College, if possible.
Purple, amazing. And look, we get to do a little bit more science and art here because do you all know what 2 colors that I have that you can mix together to make purple?
Ooh.
It's 2 primary colors.
Ooh. It's not orange and red.
Not orange and red, but you're close. It's red and blue.
Blue. Oh. Okay.
Awesome. So I'll put in some red food coloring and drops. And this is again where you might want to make sure that you ask your grown-up before you do this. Food coloring can wash out of your hands and other things, but it can sometimes get a little bit messy. And your grown-up might have a certain spot in the house that they feel comfortable with you doing this experiment. So we've got some red and we've got some blue, but we have to mix them together. So I need to get some dancing moves on again. If you all can get ready to help me shake it up. So I'm gonna put my top back on. Let's see if we can make some purple. Here we go. Shake, 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 shake. Shake, 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 shake. Okay, so we've got some purple. It looks a little black, but that's because it's dark. I think once we do add some of our next things, we'll get to see a little bit more of the purpley color. So we've got this all mixed up in our bottle. Now, the next part is where this is where it can get a little bit messy. Okay, so I want you to keep that in mind. Talk about this being messy. And this is what scientists do when they make a hypothesis. A hypothesis is different than just a guess, right? A guess, you guess anything, but a hypothesis is a smart guess. So you use what you already know to think about what might happen. So we already know that this could get messy. Thinking about that, I want you to make a hypothesis and think. In just a minute, I'm going to add a little bit of this yeast with some warm water that's been mixed in. I'm gonna put this into my bottle of hydrogen peroxide, soap, and dish color or food coloring. What do you all think might happen?
Wow, it's gonna get messy. The bottle's gonna explode.
Ooh, okay, the bottle might explode. That would definitely be very messy and definitely why you would need a grown-up. That's true. That is a really smart guess. Great hypothesis, Jed. Monica, any hypothesis?
I think it's gonna start bubbling, maybe.
Ooh, okay, what makes you think it might bubble?
I don't know. I know that yeast makes things rise, but I don't think it's gonna explode. I feel like we'd need like some sort of like acidic base for that. But
Yeah.
I don't know.
Well, that's true. Yeast does make things bubble. I know, Monica, we've talked before, you've talked about baking things in the kitchen. So I'm going to talk a little bit more about that a little bit, but you're right. Yeast is usually used when you're making something like bread or cupcakes or cake, and it's what makes your bread really fluffy, right? So your bread's not like a flat tortilla or a flat cracker. It's what makes bread really light and fluffy. So that is a great hypothesis, a great smart guess. Are you all ready to
I'm
see what
ready.
happened? Okay. I'm going to put on some goggles for this, and I'm also going to get the cap ready because we might need to shake it up a little bit. So we're going to see. So I'm going to pour it in. We're going to watch what happens next.
I got my goggles on too.
Okay, if you have goggles, if you don't have goggles on, that's okay. You don't really need goggles. I just like to use them just in case, and it helps me feel very scientific. All right, here we go. We're going to pour this in, and then I'm going to shake it up. Here we go. Shake, 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 shake. Okay, and I on 3 am going to open it. 1, 2, and
3.
let's see. Oh, I might need to add some more yeast. Okay, this is part of science, right? So part of science is that you sometimes. Oh wait, here it is.
There it
So
is.
what is happening?
It's like get all over. It's like
It's bubbling. I saw bubbles.
It's bubbling. It is starting to foam out. And I'm not sure if you can tell. And so for those of you listening, I know you definitely can't see, but it feels just like toothpaste. So it feels super foamy and it's starting to bubble over in this way that is almost looking as if it is the size of toothpaste that you would use for an elephant. Because elephants have pretty big teeth, right? They have very large tusks. So we're starting to see this whole tray is filling up with this toothpaste-like material. So I want you all to think, why do you think this happened? Why is it bubbling? Jed, the bottle didn't explode, but there was a little bit of an explosion, right?
I guess, yeah, because it and like the bottle was strong enough to keep it inside and just pushed up the top. And
Yes.
but there's some kind of reaction with the yeast and the peroxide stuff and the color and
Yeah. So some kind of reaction. Monica, do you have anything you want to add to that? Do you think you might know why? I know you were talking about yeast before and acid.
Yeah, I think the peroxide made the yeast, or they combined and then it exploded, but it didn't explode because the bottle's still intact. So it might have just like upward trajectory, like Jed was, but I saw bubbles, so I think my hypothesis was right. I'm taking the win on that one.
You are both correct. So there was a chemical reaction that took place. So anytime what you put together changes, that's a chemical reaction. So when you mix things together and then they start to look different, that's what a chemical reaction is. And we had a chemical reaction today, but we used something really special. So we could have noticed a couple things along the way. When we mixed the hydrogen peroxide and the soap together, that was already a chemical reaction, right? Those were two things mixing together. Then we added some color, but what we also used was yeast, and yeast is something special. It's a catalyst. And so a catalyst is something that makes a reaction happen much quicker, much sooner. So this reaction of mixing the hydrogen peroxide and the soap, it probably would have caused bubbles at some point, but because we added a catalyst, it had it happen a lot faster and a lot sooner. So it's a pretty cool, I don't know if you can tell, but my whole tray is now just toothpaste. Wow. So I thought I could, if I had a pet elephant, I would walk outside right now and go brush his teeth.
so you would. Am I right in thinking that there are things that are like there are chemical reactions going on all around this, but like so slow because there's no catalyst and we're not even noticing it?
Yeah, that's true. So there's different chemical reactions that happen in really small ways every single day. Yeast is a natural catalyst. So it's like Monica was saying, we use it when we're baking. And so if we didn't use yeast, if we didn't use that natural catalyst, we wouldn't see things like bread rise and we wouldn't be able to cook in that way and change things in that way. But yes, there's chemical reactions that happen in all different ways all around us. Even something like rain or snow are reactions that are happening in the sky for things falling down. So chemical reactions happen all around. Some of them are smaller and some of them don't happen quite as quickly as things that have a catalyst with them.
This might sound silly, but I'm just curious. Like when your little brother comes in the room and he makes the older kids like go crazy, is that a catalyst or is that something else?
You know, that is maybe not a chemical catalyst, but it's definitely a catalyst for reaction. So it definitely causes things to happen sooner.
Can confirm.
I don't know about you, Monica, but I think that visiting the San Diego Children's Discovery Museum would be so much fun. What do you think's going on out there?
I don't know. I think I'm dying to go. I mean, I love Puerto Rico, but I kind of want to go to the San Diego Children's Discovery Museum. What else can we find there other than this awesome elephant toothpaste mixture?
Well, at the museum, we love to do hands-on learning. So all of our exhibits, all of our programs integrate streams, so science, technology, reading, engineering, art, and math, purposeful play, and social emotional skills, and all in a hands-on way. So we have lots of different programs. We have programs that are free with admission every day. And we have different rates for our members and our non-members.
Hey, where can people go to find out more about the museum and get your address and hours and all that kind of stuff?
Yeah, so we're located in Escondido, California, at 320 North Broadway. But if you're not in Escondido or in the San Diego area, then you can always go online to our website at sdcdm.org to find out some more information. But we also do some really cool things online. So you can follow us on Facebook or on Instagram at SDCDM320, and we post all kinds of things all the time. So we have free experiments, that directions for experiments like what we just did that you can do at home. So different stream activities. We also have a lot of really fun educational videos that you can watch, whether you're a caregiver, a kiddo, or a teacher, that teach about all kinds of different STEM topics.
Awesome. Awesome. Well, thank you so much. We've had a great time figuring out how to learn how to make elephant toothpaste.
Yes.
With our friend Whitney Raser. She's the director of education at the San Diego Children's Discovery Museum. Hey, Monica. Hey, Whitney. Thanks so much for being with us.
Thanks for having me, Jed. Thanks, Monica.